this afternoon. Yeah? Great. Yay! Okay. You could do better. Okay, anyway. Today, with HORACIO, we are going to talk to you about DevOps, platform engineering, a lot of buzzwords, but what we want to do is go behind the hype, okay? And for that, we will go back to the past to explain a bit everything that happened in IT since 30 years, okay?
Okay, let's go.
Let's go. So who are we? Who are you?
I am Horacio Gonzalez. As you can maybe hear, I am a Spaniard living in France, so my accent combines the worst traits of both Spanish and French accent. Yeah, it is possible. Sorry about that. I work as DevRel, developer relation at Clever Cloud. And you?
I'm Sébastien Blanc. I'm half Dutch, half French, so I also have a weird accent, but a really sexy accent. And I'm a dev advocate at Ivan, and yeah, that's it. What are we going to talk about today?
We are going to talk about how in the last 30 years we have been adding layer over layer of complexity to the development process. Very shiny complexity, pretty complexity, but complexity.
I love this knife.
30 years ago, writing a Java program was like that. A Java class, maybe some jar, some dependencies, Java compiler, a class path, you had a .class file, you executed, and your application ran. Wonderful. Today, a new developer who begins to code in Java needs to understand a lot of different concepts. And as you are smiling, I guess you agree with us. In fact, if I was a student, I would be really scared beginning now to develop.
Yeah, because as a student, you want to try out everything.
Yeah. So we are going to talk about platform engineering and how, if it is well done, it can help to reduce that complexity, all while empowering developers.
Yes. But let's go
Let's
back
go.
to the past.
Yeah, because as you can see, we begin to get old. So we love to tell stories. Let's talk a time almost forgotten.
When internet was so young.
Yeah, when Windows 95 was hype.
I loved Windows 95.
It was really nice at the time. When companies still use mainframes.
Yeah, and I know we are still using them, but...
Okay. And at the time, those Java developers were developing their application and deploying them in bare metal servers with some operations teams that took that Java class, the Java jar, and ran it in data centers that were, everything was rather static, but it worked. It worked really well.
Worked pretty well, but the issue was all those big companies that started to create their first IT project, they tried to use what they were used to do, apply industrial model to software development. And that was not working really well.
But not only industrial model, also all the typical industrial and corporate practices, hierarchy, separation of concerns, silos, corporate politics.
Corporate silos. Yeah. But yeah, again, they were managing IT like they were managing factories because they didn't know how to do otherwise.
And look, that poor cat. You are going to see it.
Yeah, the cat is not really
this,
happy.
in this presentation.
But beyond everything, in the end, Bash will still be used. You will see this slide a lot as well.
At the end of the 90s, tooling begins to evolve. And it is important because in order to evolve the way how software was developed, tooling was needed. Tooling was an enabler to change development.
Yeah. Because you remember those times, who has used Eclipse to make a RAR or an EAR file to deploy it to production? Yeah, we were all doing that. And you remember going on Apache Commons, grabbing the jars, putting them in a folder, and then writing your end script?
And going every month to see if a new version
was available. Ah, awesome times.
And the tooling began to make that change. Because without the right tooling, everything was manual. For me, the first tooling that began to change things was source control.
Sure. Yeah.
Somebody here remember CVS?
Yeah. I'm looking at the face. Yeah, you should remember clear case. Sorry if you had to do clear case in one part of your life. But yeah, that was the really big change.
It was better than copying and renaming folders.
Yeah. Better than printing out two versions and comparing that, because I've worked with someone who didn't believe in CVS, and he printed out the two version and he was comparing that like that. Real story.
And what about having dependency management?
Oh,
At the beginning with Ant and Ivy. Do you use Apache Ivy?
no one has. Okay.
And of course, Maven.
Maven for me was a really game changer. And remember that because we will talk about that later. Maven was the first declarative tooling where you describe the desired state of your application.
So we have source control and dependency management.
Yes.
What about testing?
Testing is doubting.
Yeah, but now we can doubt automatically.
Yeah, that's true.
It's
Yeah.
better. Do you remember Hudson before they killed it and Jenkins was there?
Yeah, and Continuum, that was from the same project as Maven.
So also testing. And of course, if you were in the ops side, it was the beginning of supervision tooling, what now we fancily call observability, with things like Nagios. Before that, you only had something telling the app is running, the app is down. Now you could begin to get some metrics and some more meaningful state. So all this tooling really changed. Really allow to make the development process more industrial too. But
Again, it added a new layer of complexity. The developer had to learn all those tools.
for a good thing,
Yeah,
but it added complexity.
it had a complexity. And of course,
And of course, many people still use Bash for a lot of things.
yeah.
So now we are at the end of the 90s, several years after, and with the new tooling, we could begin to do the next evolution. Do you remember stream programming? The principles were wonderful. We are in 99, simplicity, communication, respect. They wanted to break down the industrial paradigm.
Yeah.
Software development was a practice wholly different of a factory, so we can do it in a different way. And what about the Agile Manifesto?
I love that.
Individuals and interactions, working software, customer collaboration, responding to change. It was really wonderful because on paper, it was nice.
Pragmatic freedom, breaking the silos. That's the solution to help development, software development.
For some time, I really believed that it was going to change things for some time.
But, as always, there's a dark side. That's my slide. I was allowed to put him. I let you enjoy a little bit. Yeah, because agility, where it was all about freedom, pragmatism, they started to put a framework around it called Scrum, called Safe.
Agility was too agile.
Yeah,
I guess.
it was too agile. So I had to change that. And the whole business came around that. And what about agile tooling?
Oh my God, agile tooling.
Agile tooling.
Who here loves Jira? Really? For real? I don't believe you, sorry.
And the crazier thing, we told you that they, in the beginning of IT, they tried to apply the industrial models, but because of all this bullshit of Scrum, etc., with sprints where they cut all the tasks in smaller tasks, well, they did exactly what Taylor applied to build faster cars and, to build cars in a faster way. And in my opinion, Agile is just bringing back to the industrial model. So
Not agile, but all the framework around agility, codified agility.
the codified agility. But we had a solution.
Yeah, because now we are 10 years after and we begin to learn about DevOps. Hey, we are going to break down silos. What I have heard already that the silos between developers and operations and making everybody work together. Again, on paper, it was really wonderful. Well, on paper, because as the DevOps topology site explained, there are many different ways to say we are using DevOps and using all kind of anti-patterns. Dev and part ops, devs over ops, DevOps without ops, DevOps without dev, whatever. But my favorite one is when I began to see job offers for DevOps engineer. It is a real definition for a site, I won't say it. That's a DevOps engineer.
The same company that does Jira, no?
Oh, why do you spoil? Please read it. Do you think there are somebody able to do all that? Especially a junior? But that was the beginning. Then we begin to read about DevSecOps. Hey, you take that and you add security. Dev machine learning ops, okay? Dev data ops. Dev AI data sec ops. Dev anything ops. I beg you go to your LinkedIn and put in your description dev anything ops because, hey, read job offers. So really,
Yeah, and again, just like with the tooling, etc., we end up with a cult of agility and DevOps, which added again a lot of complexity, and of course,
people
Bash will
still
still
use Bash.
but something new happened after that.
It is going to change things.
Yeah, the cloud.
Hey, the cloud. Everything began with the virtualization, and at some moment, a big company was doing online retail, Amazon, not to call it, decided, hey, we are using a lot of infrastructure that is sleeping in our data centers. We could try to let people use this infrastructure and pay for the time they use it. It was the beginning of public cloud. It was really interesting because it moved lots and lots of things. For cloud providers or for hosting companies that become cloud providers, it means they had to automate a lot of things. The automation revolution was fueled by public cloud because you have on the bottom your physical resources and you wanted to make an abstraction layer and be able to spawn at demand whatever your customers wanted. So you needed automation. There was no ops person generating the virtual machines. But also for the users, it was the beginning of self-service. Before you had to find some purchase order and then some 2 days or 3 days later you had your server. Now you did click, 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 and you had a Kubernetes cluster. Self-service was very important.
Yeah, and we as developer, we love to click, click, click. We were empowered. Infrastructure just a click away.
Because before, developers has to ask the purchase people to get a server. Now, everything was beginning to be self-service. And distributed became the default. Everything was distributed by default. When you heard cloud native, in your head, it means distributed by default, for better or worse. But another revolution was there because everything we have said meant that sysadmin ops began to had to code. The day-to-day job of a sysadmin, it wasn't to manually do operation, it's begin to see how I can automate the generation of the virtual machine, the networking, whatever.
Yeah, so sysadmins who code, we created a new name for them.
Yeah, because it isn't sexy. What about?
SRE.
What the heck is a system reliability engineer, Sebi?
It's a sysadmin who codes.
Ah, okay. But with a fancy name and a fancy salary.
And a fancy salary.
Okay. So, but for our developer, before they only need to know what web server and what database they were using. Now they go to the cloud provider site, and there are 250 products different with fancy names, and that's only one of the 3 cloud providers the company is using. And it is their responsibility, because of self-service, to choose the right product. Complexity?
Complexity, and of course, Bash will still be used.
But it wasn't the last revolution, because we developers, we love hype and adding layer over layer of hype. Because automation made another thing possible, declarative infrastructure.
Oh.
For many developers, it begins with something rather interesting. Containers. Hey, now putting things in production is easier than ever. You have some containers, and you are putting in production the same thing you have in your laptop. It is wonderful, no?
I love it. I love container.
Yeah, but what about sysadmin? Hey, because it isn't a production architecture. That's a production architecture. Container or not container, you are going to do everything as before. Yeah, but it is nice. So we can begin to do another evolution. What about microservices? We take our good old application, and to say it is bad, we call it a monolith, and we decide to split it in 20 different applications. It is nice because every developer can play with their own application. It is nice. But what about our sysadmin? Now they need to put in production, to keep in production, to monitor 20 different applications. So we need a solution. As usual, a solution is adding a new layer of hype to solve the problem and to add more complexity. What about a way to make these containers work together easily, automatically? Kubernetes.
Yay.
It can do deployment, scaling, monitoring, repairing. It is wonderful, no?
Yeah, it's what you could hire an intern
Yeah.
to do that.
Yeah, it's your electronic version of an intern. It does everything. When the intern arrives to the company, you tell them, hey, you are going to deploy this, that. Where? You have the computers there, do it. And how? Hey, you are an intern, you know how to do it. And you are going to keep it monitored. There is a problem, you solve it. And I am going to go to the coffee room. That's Kubernetes. So, seems wonderful.
Yeah.
With its declarative architecture and all that.
And the really important thing, the desired state. Kubernetes, we often say it's a container orchestrator, okay, but the most important thing is Kubernetes is a place where you can define desired state of your application systems. And Kubernetes makes sure it will respect your desired state.
So it is wonderful, but a new layer of complexity. You need to learn how to read those awful YAML files. You need to understand lots and lots of concepts in order to know how to deploy your small application, but it isn't enough because we begin to go further in the infrastructure declaration. We also have infrastructure
as code, because to deploy your Kubernetes, you need your virtual machines, your infra, and you have a few options for that. Ansible, Chef, Puppet,
Terraform.
OpenTofu.
Even if Terraform now and Ansible have the same owner,
and it will be called Terrible.
Terrible, yeah. So containers, pod, terrible. So much more complexity, terrible indeed.
And the cat is still not happy.
And Remy is still using Bash.
And Remy is still using Bash, yeah.
So let me do a brief of that. Becoming a developer in 2024. Right now, you arrive to the university. I want to be a developer. Well, yes, you can. You are going to learn Java, but in order to deploy, you are also going to learn Git. But you are going to learn to use IntelliJ. You will maybe need Redis, MySQL, MariaDB, Kubernetes, DevOps, Ansible, Terrible, whatever.
What was the CEO again? Oh yeah, MariaDB.
Yeah. So, too many options. I would be really scared, as I said, but also big responsibility because you have self-service.
Yeah.
Hey, you can choose whatever you want. It is scary. You must justify after that why did you choose that and all that.
Yeah, exactly. And all of this brings cognitive load to the developer, poor developer. He has to deal with so many things, so many things. How can we help our developer to remove this cognitive load and still enable self-service, empowering the developer?
One of the answers could be platform engineering. I could say could be because this morning we were discussing with some people about the topic and they say, yeah, now you can say it is solving the problem because it is early in platform engineering. I can bet that in 2 years you will see how platform engineering has still added a new shiny layer of complexity. But for the moment, the idea hasn't still been corrupted by the usual actors. So
We will do a talk about that in 2 years, probably.
yeah, we promise we will do like the talk.
It's a nightmare of platform engineering.
But for the moment, the idea is really easy. That's the definition you can find in a paper by Luca Galante about platform engineering. It is very complicated. You can try to decrypt it for us, Sebi?
So basically, it's we have all these tools that we want to provide as self-service, but at the same time, we don't want it to be open bar for the developers. We want to streamline it to make it easy for them. There are some processes that we want to make sure when a developer, for instance, wants a Postgres database, we want to be sure that some schemas are there, that some error bug rules are there. But we don't want to add this cognitive load to the developer. So a platform team will be sure to create an offering for the developer that is streamlined. And yeah, basically that's platform engineering.
For me, a good metaphor is curation. You have a lot of possibility, and you are going to choose a good set of possibility, and you are going to present it in a coherent way to your developers to make them have at the tip of the hands all the needed options without having to think about how can I use a MySQL? I can install it, I can use this provider, this other provider, I can use this service, I can... No, okay, you have MySQL, you have one way to do it. So making things easier, or as they say in most of platform engineering presentation, creating a golden path from the developer's needs to the solution. Yeah. There are many ways to solve problem. Let's choose one way for every problem and present that in a coherent fashion. But for me, that's the...
Yeah, but is that something new, honestly?
Not really. I think most companies have been doing that for years.
For years and years. I've been working for with big accounts, and they all have their platform, but they didn't know it was called a platform. And the issue most of the time is they made their homemade platform. No?
I remember.
And of course, the developer creating this platform left the company.
Yeah. I remember 15 years ago, I was working in a bank who wanted to do a developer portal and doing everything based on portlets. It was a kind of...
Jet speed.
Yeah. And you had to, you didn't write application, you wrote portlets, and you deployed that in the portal, and it was something, yeah, it was homemade. Now, the idea of platform engineering is not to reinvent the wheel every time, trying to create a platform based on open tools and standards, and try to be able to maintain it and to make it really useful for developers. I mean, reducing complexity, but giving all the power needed for the developers to do their job. I like to say most developers, what they love is to develop, to write code.
Yeah, and a sprint retro meetings. No, I'm joking.
Yeah, For me, two of the big problems are meetings and all the tooling you need to learn in order to know how you deploy your application. I cannot do anything about meetings, sorry about that. But about the other part, platform engineering can help.
Yeah. So how can we set up this new cool kid on the block, which is called platform engineering? How can we implement that in our company?
For me, and that's our personal take, there are three good pillars. The first one is GitOps. We are going to see it, but having Git as source of truth is a good way to streamline things. Another, and that's really important, is team topologies. I mean, organization must adapt. Having a platform, it isn't free. You need to have people dedicated to make that platform work. And of course, you need to follow some principles in order to allow the platform teams and the platforms itself do their job.
Yeah,
We
exactly.
can go into detail.
Let's go for GitOps. So once the platform team has created those self-services and put it on the shelf, how will the developer consume that? Okay, and if we take the option where the platform is built on top of Kubernetes, there's a big chance that all those services will be just custom resources. If you don't know what it is, in a few seconds we will explain what it is. But these are custom resources. How can the developer apply those custom resources? You could give them access to your Kubernetes cluster, but I'm not sure you want to do that.
And that's true also for non-Kubernetes. In any case, your developers are already using Git. And most deployments, you have either Kubernetes or a CI/CD or whatever, are already based on Git.
And
Your infrastructure, if you are using infrastructure as code,
exactly.
it's already on Git.
And infrastructure as code is code. So you can treat it like code and you can use the power of Git. And that's the idea of GitOps. Treat everything as code. Git is the single source of truth. And all the power of Git, doing pull requests, merging branches, you can all do that. And all the developers and all the SREs know how to use Git. So that's the perfect way to provide your services
So
to
you
your
have
developers.
good collaboration. You also have visibility because you can see how infrastructure and application has evolved, and you can have a trace of all the evolution.
Exactly.
Security also, reliability. If anything goes wrong, you can get the last Git version that worked and rebuild your infrastructure from that version.
Yeah.
And provisioning and deployment, you have all the automation tooling. So take your base, your infrastructure as code, and your Kubernetes manifest, and everything from Git, and redeploy.
Okay. So now we have our main entry to our platform, which
But
is
that's a
it's
very technical thing.
that's a very technical phone. Is
Because-
that? Do you think it's enough?
No,
No.
you also need to change your organization. And if somebody is trying to tell you you can use platform engineering without putting the human effort on it, they are lying to you. One good resource about that is a book, Team Topologies. They also have a site. And it explains that there are fundamental topologies.
Yeah.
What are them?
You have the stream aligned teams. These are your development teams,
Yeah.
teams that work on the microservices, that work on the feature, on the core business of your product.
Each team in one feature or one application.
One application, whatever. And then you have the platform team that create the tools and the resources and the services.
And keep it alive and growing because a platform is never done, it's ever evolving
Yeah.
to adapt.
And of course, you have stuff like security, which are really complicated. You still keep those teams separate. That provides libraries for etc.
Expertise.
Yeah. And then you have this enabling team, which is interesting. This team doesn't code, doesn't produce anything. What they do, they facilitate. They are internal advocates between the stream-aligned team, the platform team, and the complicated system teams.
And very important, your platform must be alive. I mean, the platform that works today, it isn't work well with the needs of developers in 1 year or two. Things move too fast. So you need to keep that platform team working every time in the platform, making it richer, making it more adapted to the problems. And the enable team works with other because you have teams, but you also need interaction between those teams.
Yeah.
You can have several types of interaction, offering things as a service. For example, we talk about security. What about the authentication? It is going to be done by a specialized team as a service or the platform itself. But sometimes, hey, we need a new feature in the platform. You can give it out, or we are going to do some shadow IT. Well, let's work together, or the enable team. So the idea is you have teams, and those teams work together.
Yeah. And again, please go to this website. They explain it really well. And again, don't be scared. For sure, if you have a pretty complex existing team topology in your company, you won't be able to go to this model directly, but you should try to tend to get as close as possible to this topology. Okay.
Well, so we can begin to talk about platform engineering itself. Hey, we are in time.
We are in time.
We were scared this morning because we thought we are going to need 1 hour and a half, and it is working well for the moment.
Yeah, exactly.
So,
I'm impressed.
as I told before, the idea behind platform engineering is not cutting developers' freedom. Freedom is always nice, but if you have too many choices, there is a paradox. Our brain, it is enabled to choose. We are limiting our freedom by having too many choices because we are going to be responsible of these choices. So, by creating a golden path, hey, you need to deploy a MySQL, you need some monitoring solution, you need some instance provisioning, you are going to use that for these needs. It makes that you as developer, okay, I only need one MariaDB. I don't need to look at 3 cloud provider websites to understand what is the fancy name they use for a MariaDB database, or if I need the XSM or XL instance. Okay, I only need to know I want that, I get it, and I can begin to do my job, that is to code.
Yeah. So basically, I'll let you this slide as well because this.
And of course, if you want it works, you need that your platform teams and your stream teams know that every team is working on their part. I mean, you need to have for your platform teams a clear mission and role. Why I tell that? Because at the beginning, we talk about many companies have been doing that in a homemade way for years, but one of the problems was that they were seen like a team who were creating internal tools, so something almost worthless. They were at the service of other teams.
Yeah.
Not, it needs to be a real team with a real mission and a real value for the company.
Yeah, not just a cost center.
Yeah. And
that's the most important thing. Yeah, your platform is really, you must treat it like a product. So everything like we do in manufacturing, construction, it's just exactly the same. Your platform is a product, and you can apply all the principles how you manage a product exactly the same for your platform, and you must really do that.
That means things like beginning small and making it bigger in an interactive way. That means also getting user feedback.
Oh yeah, implementing stuff like friction logs, empathy meetings. These are really powerful tools that you can implement to make your platform better and better.
Another important thing is to focus on common problems. When you begin to develop an internal developer platform, you can do lots and lots of things. Try to look for the big wins, the 20% of problems that are common for most teams. and solve those problems. I mean, begin, hey, how can I have an instance, a server, a database? If you offer that in your internal developer platform, you will have already reduced complexity for developers team by quite a factor. And then you can begin to do more. You don't need to do something perfect. Perfect is the enemy of good. Do something good enough and your developer teams will be really happy to use it.
Best slide ever.
Another important thing, glue is valuable. I mean, the platform is a kind of glue that it is going to help your developers team to work in a better way. What's the problem? That in many company culture, these kind of things are seen as cost center. And I love this slide because I loved this film when I was young. And the idea is that, okay, it is only glue. Superman is only making a bridge between the two sides of the rail. Worthless, no? If he isn't there, everything is going down. So you need to be sure that your company understands that the platform is not a cost center. It is a productivity enable. If you don't take care of the platform, your global productivity is going to suffer. And that's very important because glue has value.
Yes, exactly. So,
And another thing, you want to create your developer platform. Yeah, nice. It isn't the moment to try to reinvent the wheel. You have many nice ideas, but the development platform, if you want to avoid the homemade syndrome, try to do market standards, try to do something quickly reproducible, try to do something that if you quit the company, can still be alive.
it can still be alive, yeah. But even if you make the nicest platform, in the end, you will still have some bench.
No, in fact, in most of these platforms, it is going to have a lot of bash inside, but in a current way.
Yeah. So concretely, let's imagine that I want to build my internal developer platform using Kubernetes.
He loves hype. Okay, let's do it. We are going to build an internal developer platform in Kubernetes. What could I use?
The first thing is to make sure that you don't put everything in Kubernetes. I told you.
But I can. I can put my databases and everything into Kubernetes. It isn't a good idea?
Not sure.
Okay.
And you could. You should put your Kafka at Ivan.
Okay.
And your Postgres at Clever Cloud. No, just a joke. But the important thing here and again, Kubernetes is just not a container orchestrator, it's way more than that. You can operate all those external API services from within Kubernetes.
And that's better than trying to put everything into Kubernetes. Kubernetes is an orchestrator, but it is not only that. You can use it as an automation center for your infrastructure, and one of the key points to do it is using operators. Yeah. Operators is a Kubernetes resources that is a fancy name to something that uses two standard Kubernetes objects, the custom resource definition, CRD.
CRD. For me, that's the most powerful feature of Kubernetes.
It's the capacity of Kubernetes to create new kind of Kubernetes objects. For example, to represent your external database on Clever Cloud and your external Apache Kafka on Ivan. Yeah.
And you benefit from the power of Kubernetes, so the reconciliation loop,
the
scaling,
the declarative,
the scheduler,
and
everything.
then you have the controllers. I have drawn them as the Sauron's Eye. Why? Because they are reconciliation loops. They are every time looking, what is in the cluster? What you have asked me? It isn't the same, I am going to act. And every time they are looking around, trying to make that the things in the cluster or the things in your external resources, the things you have defined, are agree with the definition, with the desired state you have given. So you can create or use operators for your external resources, your legacy application, whatever, and control them from Kubernetes. And you are lucky. There are lots of already available operators. That's an operator hub. And they are
A lot of operators.
really a lot.
And probably what you will do, you will create your own operator.
And if you are in DevOps, usually you love Java. It is nice. One of the best way to create Kubernetes operator is using the Java operator SDK.
Yeah,
And it is not difficult.
no. And if you are really smart, you will use the Quarkus extension
Oh, yeah.
to build your
So that
Java
means
operator.
that we are controlling everything from Kubernetes using operators, and we have now a lot of shiny new operators in our cluster. I think the cat is sad again.
Yeah, so again, we have added complexity because we have all those operators. We have created a lot of operators.
We could create an operator to control all
We could-
operators.
We could create an operator to control
No.
operator. It's not totally stupid. It's one way of doing it. But
He's nice with me, you see.
but you can use other tools. One tool that I would like to highlight here is a tool called Kratex, which address exactly this issue. Imagine you have, when a new development team start a new project, they need a Postgres, a Kafka, maybe they want their service to be serverless with Knative, etc. So you have to use a lot of different operators. But again, we want to streamline the offering for the developers. What you can do with Kratex is define a simple CR, custom resource, okay, which abstracts everything for you. And then in Kratex, you build a pipeline that will take this CR and create specific CRs for all the operators that he's abstracting. In the end, you end up with a custom resource that we call a promise. And that's the only thing that the developer has to use. So it's an open source project. Really play with it. It's really, really powerful. And again, it really addresses this issue of bringing down the complexity.
And of course, using Kratex, we are giving a GitOps solution to our problem, because for developers, they are going to work using Git, sending the manifest to Git, using those resources given by Kratex, and using a CI/CD, a GitOps pipeline like Argo CD.
Exactly. We had to
already
pick
works.
one, and we picked the one that we preferred, Argo CD. So if you want a simple solution, and you can install it with an operator, if you want a simple solution to start with GitOps, I really would advise you to take a look at Argo.
So using Argo CD, Kratex, and operators for our external resources, we can have an internal developer platform on Kubernetes without having to reinvent things. Nice.
Yeah, really nice.
But what about I don't want to use Kubernetes? It is possible somebody wouldn't like to use Kubernetes. Yes, it can be, because for me, most developers, they want to develop. This was nice. It was a bit old school. Maybe we can simply do things like that. I write my application, my Java code, if I'm a Java developer, I put it in Git, and I don't care about having to write a Kubernetes manifesto, having to write a Docker file, I only want my code to work. Another way to do that, if you don't want to make your developers understand all those concepts, is using some platform as a service way of doing things, some Git to prod workflow. There are many. Today I am going to talk about the one I prefer. I work for them. So, for example, using something like Clever Cloud, you are going to create from a Git repository, you are going to create the runtime and the data source and everything your application needs, and you are going to link that to your Git repository. And from that moment, the only thing your developer needs to do to deploy is only to push in the production branch of the Git repository. For me, that's the thing that reminds me more the old way, not complex to do things. So if you love Kubernetes, you have a hyper nice solution. If you prefer a Git to prod workflow, many solutions, I suggest this one, but you have many others.
Yeah.
And we have some time for question. It is wonderful. Let us finish with some links. That you have a link to the past. You have many links there. The idea is everything we have talked. You have here the links. We are going to put the presentation on Twitter and on LinkedIn later today, so you will be able to look at that.
Yeah. And if you understand French and you want a longer version of this, we did a 3 hours version of this
With
talk.
some nice demos
With-
that we couldn't do here.
We couldn't do here, demos.
And it is wonderful. We have 5 minutes almost for questions,
First time it ever
for
happened.
feedback, for whatever. So please ask away.
No questions?
No questions, no.
No.
Yeah.
Oh, there's one question.
So can we have some? Can we use the mic for the recording?
Whoa.
Okay, thank you. So if I'm working in a big organization and they don't really have some platform engineering formalized, do you have some ideas that I can do inside my team that is of 10 to 15 engineers to have like these patterns in order for everybody to have a common micro stack, let's say?
For me, and it is my personal opinion, the first step should be trying to gather some support from the organization level. Because you can begin to do some tooling, you can begin build things, but the most difficult part is to get traction. So for me, at the beginning, the advocacy part, being able to get together people, and we need that, not only my team, almost every other team, we try to make the hierarchy commit some time and some budget for the project. And then you can begin by identifying the quick wins. So if we have only 3 things, what will be the 3 things that would help your team the more? Maybe having an easy and unified way to get instances, databases, and CI/CD. Okay, do that, because you can create a quick POC, proof of concept, and then when it works, it is almost magical. Everybody is going to get to say, hey, I am supporting that, because you see that it's so support and quick win.
Because my company had some initiatives for platform engineering, and the divisions were break down different teams, and now we're in the place where if you want a Jenkins, you have 3 developer portals where you can take a Jenkins. And then you ask your colleagues, okay, who knows what's the best option? Oh, I think these guys, because I know they're still active, they still have 5 guys in the team. Don't use that, because
That's why we talk about team topologies. That's usually an organization problem.
so a team, I'm asking this because I'm a team lead back in my company, and we 15, so we have 3 options to take Jenkins servers, 3 options to take Artifactory servers. We could use Terraform Enterprise because we have Terraform Enterprise accounts, but we
Like
also have
many big
Pulumi
companies.
Enterprise. Yeah, but I want to, because if we extend or build
You
other
can
teams,
create some kind of guild or a squad working together to say, from these 3 options I have, what are the ones we should use? Maybe defining some guidelines. It can already help, and then trying to combine other teams to use the same guidelines. Because having 3 possibilities, it isn't so bad if you have clear guidelines. So if you already have all that, try to get a consensus on what are the situations that you will use Terraform Enterprise, or when are we going to use Ansible, and why, and giving these guidelines. And it can make people converge to the same way of doing things, and then you can begin to try to simplify that. It's my point of view.
Yeah. But then again, it's easier to say than to do.
I know organizations where platform engineering was. You know Picnic, the company in the Netherlands?
No.
Okay, they have a really interesting tactic. They really did this platform engineering very good.
Okay.
Thank you.
Yes. Thank you. I think
Some other questions? We have 1 minute.
otherwise we can give you back 1 minute of your life.
So thank you very much. I hope you have at least find that interesting and maybe help you to begin to think about this matter. And if you want to discuss, we are going to be here after the talk. Thank you very, very much.
Thank you.